So friends, it's a great pleasure for me to be in this audience and to be able to say a few words. It's indeed a pleasure for me to be here to participate in this felicitation function for Naba Mondal, whom I knew almost from the day he entered TIFR. Naba Mondal, to sum up in the beginning, Naba Mondal is an accomplished experimental physicist. He is very dedicated, motivated in everything he does. And I think he is a role model for the youngsters. And they have a lot to learn from him. Just to try to jot down a few points, but then most of them already people have covered, particularly from his entire activities by Sudeshna and the very early days of his entry into TIFR by Professor Srikantan. My first impression of Naba Mondal in the first few months of our association was that he has a very special aptitude for circuit design, instrumentation, detector building, and data acquisition systems. And also the other impression was that once he takes up a job, he would pursue it aggressively until he sees the end of it. I mean, these are the two qualities by which I think they run through his entire career as of today. When he joined, I think as Professor Srikantan said, this is a very appropriate time for any person to get involved in experiments in particle physics or cosmic rays. Because I think the air was thick with rumors of possibility of doing proton decay experiments and in other laboratories, and the predictions by SU5 and other models of gut theories by Glashow, Weinberg, Salam and Pati, that the possible lifetime of protons could be very close to the achievability by the current day experiments. By the current day means 1980s. In fact, by looking back at the data, both at South African mines and from KGF mines, the data collected at very great depths, it was possible to bring up the limits on the proton lifetime, the lower limits on the proton lifetime, to as close to as 10 to the power of 30 years, which was tantalizingly close to the predictions that were available at that time. Nobody would like to lose that chance. It's a great opportunity. And that is the time when Mondal was with us, and particularly he had a little bit of training in the underground experiments on multiple muons we were doing at that time. And simultaneously we have been recruiting, as Srikantan said, we are not able to get enough scientists to get into these programs. Firstly, to do an experiment underground and environment which is not like TIFR is very difficult to get truant. If you stand in there, he will never go back. Okay, this is the kind of problem we used to have. But then we wisely invested in recruiting a large number of engineers who are very motivated, very young and very fresh. Many of them are sitting here. Satyanarayana is one of them. Punekar, Kulkarni, and Kalmani, and Reddy. And in fact there are some others who are not here and who all had Nagaraj, P.S. Murthy, Mittal, earlier batch of Wankar, Salvekar, These are all the people who have made great contributions in terms of, keeping up the tradition of building detectors and running them underground continuously. So, in fact, Mondal has the ability to put all the things together and all collect all the people and bring them into a team who would work day and night to do either the electronics or data acquisition, monitoring, detector building, whatever. And I think they all loved to work with him and also loved to learn from the experiences that they gained from him and others at that time. And just another point I want to mention is he had a great colleague, Dr. Hayashi, who is a student of Miyake, who is an electronic buff, and he is also very good in analytical analysis of the data, the background, etc. And these two people have gelled together very well, and they were responsible for, really speaking, designing, building the data acquisition system for the large experiments underground, particularly the two proton decay experiments, the phase 1 and phase 2. In fact, I would say that the first phase of the experiment was a very harsh environment without any air conditioning. And it was necessary to build in such a way that the things run continuously for years. And they made great effort in achieving that. At that time, of course, there were the kind of state-of-the-art DAQ systems. At that time, about 1,000 to 2,500 channels in 1980 using microprocessors and operating deep underground. That is the kind of technology that they have brought in. Of course, his PhD was obviously on proton decay, and as you all know, the limits that we have obtained at that time were very modest, few times 10 to the power 30 or 10 to the power 31 for E plus pi 0 decay mode. But then I think that was the first experiment dedicated in the world, and it was mounted within a period of about 11 months from the time we have been given a go-ahead. And I must say that it has certainly the kind of result that were coming out of that was such that it has encouraged many other groups in the world. I am very sure of this. Many other groups in the world to go in for large-scale experiments. Many people moved into the neutrino experiments. Of course, while doing this proton decay work for his PhD, he has also looked at the gut monopoles and the bread and butter stuff like cosmic fermions and neutrinos that you cannot avoid recording in the detector. And a number of papers have been written on this. So just between the phase 1 and phase 2, he decided to go on a sabbatical to USA. The first thing he did was, I think, he went to Oregon and looked at the trigger logic for the proton decay experiment, Sudan 2, with Maury Goodman and others. And after a year or so, he moved on to Fermilab, where, as yesterday Adam Para was saying, that and also the photographs were showing, he worked on the tracking detectors for CDF. I think it was a very good experience and also a very good job that he has been able to do at that time. Why I am saying this? This has provided an ideal platform for him for getting involved in large-scale experiments in accelerators. And at the same time, things are getting bad in Kolar goldfields in terms of threats from the government that they would close down in a year or two, and we bargained with them for another 1 or 2 years, and so that we can complete whatever we are doing. At the same time, have enough time to pull out all the equipment, about 500, 600 tons of equipment in all parts, from a depth of 2.3 kilometers and 2 kilometers. And so that took nearly about 6 months to 1 year, in which many of us had to participate. Forget about physics and all that. We had to just get rid of this stuff so that it doesn't get flooded in the mind. But that also gave us an impetus to get into the accelerator experiments. The absence of any reasonable place in Kolar goldfields. And I must also say that there was no great new idea of neutrino physics at that time on the market to be able to do, come what may, an experiment and save that mine and all that. So naturally we moved on to the accelerator experiments at Fermilab, because that is the place to go. And the D0 detector was just getting built. CDF was already up. And then after, I spent about 2 years there working on the argon calorimeter, the design of it in the beginning. And then these two experiences of his and mine was just adequate for us to jump into the fray. And we wrote an MOU, and then we decided that we will build the veto, cosmic veto for the entire detector. And in fact, Suresh and I have shown one side of the photograph. The whole detector is enwrapped with this. If you go and see the D0 detector, you will see only these covers, nothing else from outside. And it is a joint work with Fermilab. Most of it was done in TIFR and workshops and BRC and all that. And in all these things, of course, Mondal took a leadership role in all these aspects, and with all the engineering staff we have got, with the technical staff we have got. And as Suresh already mentioned, the physics part of it was centered around the thesis topics of individual students. That we thought is the best way to go about. Not to go for a fashionable thing, but to go for something where you can make a solid contribution. And Mondal has been able to produce several PhDs from this. And all of them are doing very well outside, and we heard yesterday about Supriya Jain. So it is around it after the discovery of the top work by CDF and D0 in 1995, and after a year or so we have decided to look ahead and think of what is the next step. And that is when we have the offer from CERN to get involved in the CMS experiment. Already there is a group which has signed up, the group led by earlier Professor Malhotra and then Ganguly and Gupta and others. And then as a group we wanted to move into that from the high energy cosmic ray group. So what was done is essentially to identify a piece of equipment that can be built in India by us in collaboration with the colleagues from Fermilab. And of course Jim Freeman was one of the leaders of the group from there. And this certainly has taken the help of others and the other groups like the Punjab group and BRC group and others. An overall India CMS collaboration program has been evolved, and most of the equipment has been successfully fabricated and integrated into that. There are some small problems in some electronics of due to magnetic fields in some areas of the outer head-on calorimeter. but that they are all being worked out in the upgrade. So, I am not touching upon, in fact, as somebody has mentioned, Professor Mondal has been specially chosen by us as the group from India to represent us at the India CMS in many of the meetings, and he was the main coordinator for the voyage for a long time, almost up to 4 years or so. And afterwards he has moved into the other areas like INO, so where he had to spend more time. So the INO is an idea that has been hanging around since the discovery of the signals on the angular distribution by the Kamiokande experiment, which was not entirely believed in the beginning because it needed corroboration. But then it was compelling enough for people to work on that. And the ideas were floating around, and many workshops are held. Professor Rajsekharan has played a major role in pushing forward this idea of building a detector in India. And they, of course, because of the experience in Kolar goldfields and then the first observation of neutrino events in Kolar goldfields in 1965, there was some kind of a heart pride in the scientists around, thinking that we probably lost a golden chance by not continuing. In any case, I think it's a good idea that they have pursued, and the INO is now almost is approved and almost being funded. Of course, we have been hearing for quite some time this statement, but it looks as if it is now is final. There were some problems, they had to move out from one site to another one. It was a better site. They had to move from there. And in all these things, what you need is tremendous tenacity and patience if you want to pursue any such big project in India. It may be true everywhere else, but it is much more so in India. So I think that I would only say that it is a real testimony for his leadership and ability to gather support from all the young students, researchers, engineers, technicians from all the universities, and science administrators, and even some politicians of the country. I think I can only say that I have really enjoyed my association with him, first as a guide for PhD, but for a long time as a valued collaborator, colleague, and I am really proud of his achievements. I wish him great health, prosperity, success in his research activities, and I must mention that his wife Sapna has been a great support for him, and in fact we might have taken him off the family line for quite some time, taking him to Kolar goldfields or to places like Fermilab in Geneva, but I think they understood, and his son Sandeepan also must have felt that he has missed his childhood with his father, at least for a part of the time. But this happened to me too, so. So let me conclude by saying that I think you should continue. You should forget that you are 60, and you should just continue. Complete this project of IMO. I think you will have a very happy future. Thank you very much.